Problem 20. It says, it gives 4 different criteria for basically the Venn diagrams we have. And we've got to see which of these Venn diagrams matches all 4 pieces of the criteria. Now, the first one says some triangles are obtuse. Now, what that means is in this big box it's triangles, you got a piece, some of them being acute. Well, there's acute triangles. Actually, every acute triangle is a type of triangle. So actually, it doesn't need to say some, because every acute triangle is a triangle. So no matter what we do, we go through here for some triangles are acute and some triangles are obtuse. Every one of these pictures is going to be fine for that. It's not going to break any rules there. Sort of silly piece right there. Here's the key. No triangle is both acute and obtuse. So we can't have a triangle be part acute and part obtuse. There can't be any overlap between those two categories. There cannot be any triangle that is both acute and obtuse. We cannot have any overlap between the acute and obtuse. Acute, obtuse, they're in 2 separate categories. No triangle that's obtuse is within overlapping this acute. So that's okay for right now. Down here, these little spots right in here, these guys right in here, these guys are obtuse and acute. You can't have that happen. It says no triangle is both acute and obtuse. So this guy is out of the picture because it has some overlap. It has some triangles that are acute and that are obtuse. Same thing here. We got some overlap. Acute, obtuse. There's some overlap there. These little triangles right in here, those guys are acute and they're part of the obtuse. And it says no triangle is both. So he's out of the picture. We come down here. Acute, obtuse. They're in 2 totally separate categories, 2 totally separate situations. So they cannot be, there's no overlap. So that will meet this criteria that says no triangle is both acute and obtuse. So we're down to 2. Final piece should set them apart. It says some acute triangles are equilateral. There's some of these guys that are acute that are also equilateral. There will be some overlap. Well, here, acute, equilateral, there's no overlap. There's no triangle that is both here and here because there's no overlap. And it said that there's some are. He's out. Let's check F. Here's acute, here's equilateral. Actually, every equilateral triangle is within the category of being acute. So there are some acute triangles that are inside here. This guy right here, he's an acute triangle that is also equilateral. F is going to be my choice that meets all 4 of those criteria.